The next topic that we are presenting here, not that I'm presenting, but that Taras is presenting, will be content security policy. That is a rather newish concept of mitigating, not preventing, but mitigating cross-site scripting. And it's, in my opinion, a very elegant way of doing this. But if you ever have tried to install or to activate the content security policy on an existing web page, this is rather difficult. And so it is a very great pleasure for me to present to you Taras Ivashenko. Was that right? Yeah.
Yep.
Thank you very much. He's from Yandex. That's a very big Russian provider. And they rolled out content security policy at their main site, and he's going to present what they learned about this. So,
okay,
go for it.
Hello, and for the first, Yandex is not really provider; it's leading search engine in Russia. My name is Taras. I'm from Russia, and I will speak about content security policy. It's traditional slide. It's traditional first slide. So a few words about me. I'm information security officer at Yandex product security team. What else? I'm web application security researcher, and of course yet another security blogger. If we talk about, first of all, of course, we need to talk about cross-site scripting attacks. But in 2013, it's not really interesting, because why again about cross-site scripting? Everybody knows it. So because it's still one of the most common issues in web applications. But I promise I will not show you any alerts. And we will talk about prevention. The first mechanism to prevent cross-site scripting attacks is, of course, input data validation. It's not so important, but the last one is much more important. I'm talking about output escaping, and this type of escaping should be done depending on the current context. There are about 10 HTML contexts and so on. We of course have HTML only attribute for session cookie. The most popular cross-site scripting scenario is to somehow grab value of session cookie of victim and use it somehow. So if we, for example, specify this attribute for session cookie, it will be much more difficult to do it. And currently, as I know, it will be impossible to take from JavaScript value of session cookie. We of course have some browser-side tools, for example, Internet Explorer filter, and the much more popular tool called NoScript. But also, as you might guess, I talk about content security policy. What is it? It's another browser-side mechanism to protect your application against cross-site scripting attacks. It is somehow source whitelists for resources of your application on the client side. And it's in a nutshell, it's content security policy HTTP header, and currently it is W3C candidate recommendation, but in same time it's implemented in major browsers. So if you have installed the latest version of popular web browser, looks like you have already have such opportunity to use this protection. Okay, let's figure out how it works. Let's take a look on some simple example. Here you are HTML template with some output variable. This filter called safe means that a value of this variable will be outputted without any sanitization and so on. So malicious user or attacker can exploit it, but it's not really evil exploit, but simply with inserting, for example, image. It's demo URL, it's not real attack. So if we insert this image, we will have such picture. You can see that image is inserted in your web page, and in console, in browser console, you can see two requests. The first one is to your web application, and the second one to take image from external host. Okay, images it's very interesting, but when we talk about cross-site scripting attacks and prevention of it, we of course need to talk about how can we control JavaScript. Okay, let's add some, oops, it will be in the future, and about image. Let's add some content security policy magic here. We add image SRC directive with value self. Self, it's self means the same origin of this web application. So if we take this content security policy and implement it into our web application and try to exploit it as in previous slide, we will get such alert in our console. And now we need to talk about how to control JavaScript. We add some more magic. We specify that default behavior will be browser, please load resources only from the region of current web page, and we ask browser to permit scripts only from origin and from host with static content. And if, for example, attacker tries to inject some malicious JavaScript payload from external host, for example, with such construction, it will be not triggered for user, and in console we will get such content security policy alert that script SRC directive is violated by this entry. So cross-site scripting attack is broken. It's interesting when we try to limit external sources, but sometimes but malicious user can inject some custom JavaScript payload and use it without external sources. And we can, by default, content security policy forbid such behavior. It's called inline scripts, and content security policy by default rejects such scripts. But sometimes it's difficult to remove it in your web application, and there are two keywords in content security policy which you can use to allow some kind of inline scripts and styles. The first one is unsafe inline. As you may have guessed, it allows to use inline piece of code in your application of JavaScript and styles. And what else? It allows you to use event handlers for tags. Of course, it allows JavaScript scheme, and you should not use it in your content security policy because it will highly decrease the security level of your policy, and it will be sometimes useless. Sorry. And the next keyword called unsafe eval, and it allows you to use in your JavaScript eval, set interval, and so on functions and constructions. And of course, you also should not include it in your content security policy. You should Sometimes it is difficult not to include, but if you want real protection, you need to forbid these keywords. There are about 10 directives in content security policy. I already said about default source, about images, about strips. There are also another directives called media, object, frame, font, connect. As you might guess, these directives helps you to control these types of object, of resources. And another cool feature in content security policy is opportunity to debug your policy, to get some logs from browser and to analyze it. So you can specify a special directive called report URI with some URI, and if you use content security policy in special mode called report only, browser will send to this URI special request with JSON payload, and in your logs you will see a lot of useful information about what directive was violated and broke your content security policy, what URI was blocked, and so on. So it's very useful when you try to implement content security policy in a real popular web application. Okay, looks like cool feature. So what about browser support? As you can see, there are different HTTP headers, and it's bad news because the first one is about standard, is about version 1.0, and this version and this HTTP header is supported in the latest version of major browsers. You know, it's Google Chrome, Firefox, our browser called Yandex browser, and what also? There are another directives with some prefix. Sometimes it means that browser have itself a little bit another implementation of content security policy. For example, all the version of Firefox had different keywords to allow inline scripts, and so it was very difficult to support all this stuff. And about mobile browsers, we also see that only latest version of popular browser supported, but I hope in the nearest future we will see that all major browsers support this feature, and we will implement it much widely. When we talk about some defense mechanism, we of course should talk about maybe how can attacker bypass it. And if you talk about content security policy, the first one will be about HTTP headers. So as I already said, you can specify your content security policy via special HTTP header, special HTTP response header. So if the attacker can control HTTP response header, so he can, for example, simply throw away your content security policy, or simply add some, wildcards on it. So you need to take attention on such vulnerabilities like HTTP response splitting, for example. The next problem is part of implementation bugs in browsers. Here you are example in Firefox. It's an old one example, but it's interesting because in this bug, attacker can bypass content security policy via image with event handler. So ever if you forbid to use inline in content security policy, this version of browser unfortunately was permit such handlers. So that was a a bad bug. JSON-P. As for me, I think that it's one of the worst formats in the internet today, because you know, the main purpose of this format is to bypass same origin policy. And if we talk about content security policy, this format in some situation can help attacker to bypass your content security policy, because for example, you specify some hosts as legal host for scripts, and on one of these hosts there is a special script which returns data in JSON-P format, and if callback in this JSON-P script is not good validated, attacker can control it and use it to attack your application with content security policy, because currently you can limit sources in content security policy only by hosts and host scheme and ports by origins. In the next version of content security policy, you'll be able to specify paths as you will be able to specify paths, but currently it's not possible. So if you have some bad JSON-P script on one of allowed hosts, it will be a bypass issue for your content security policy and cross-site scripting protection. Interesting thing is that sometimes we even don't need JavaScript to make some problems to the user. For example, we can use some kind of HTML, and if the user will, for example, click on some button, he will send a lot of interesting information to your server. So in this situation, you don't need to have JavaScript. And what else? About next version. As I already said, sometimes it's very difficult to remove inline scripts from your web application to correctly implement content security policy. And because, for example, sometimes inline scripts works a little bit faster than a lot of external resources included in your web application. So in the next version of content security policy, you will have such opportunity to specify special value, call it nonce, and you can sign with such value all your inline scripts. Please take attention that this value need to be different for each response. So you can sign your inline, and you will promise to web browser that it's safe code, and this code is it's yours. So the third part of my presentation is about experience. It was very interesting and sometimes difficult to implement such good feature in a really big service. So we try to implement it on our mail service. It's one of the most popular services in Russia, and it processes about 12 million messages daily. And of course, it has a lot of, tons of JavaScript on client side, rich user interface, Ajax, everything, ever sockets. So it's a really good example to implement complex content security policy. And the plan was like this one. First of all, we decide to test it on our corporate mail, which is simply instance of global mail. And if everything is okay, we will try it in a report-only mode in big production. And after that, we will, of course, need to analyze tons of logs, try to fix bugs in our application, which is dependent to content security policy, and in the future switch to block mode and get profit on it. For this moment, I can say that it's not so simple as in this plan. In real life, I say. So for this purpose, I have made a special extension called CSP tester, which helps you to test your application, to test your content security policy with your web application. What is it? It's an extension for Chromium-based browsers. It has simple and advanced modes. It supports both content security policy and XWebKit CSP headers. XWebKit is for old Chromium-based browsers. It's a great feature that it has special help links to directives to main site of W3C, and you can get it from this. It's open source. Here you are, a screenshot of it. So it's a simple model. You can see that all directives are parsed, and you can specify directly one of them, activate or deactivate content security policy for this for current web application. You can specify URL pattern for it, and after that you can analyze messages in console of your web browser, and see a lot of bugs in it. So, what changes we had to do in our big service? Of course, it's try to remove all inline stuff. It was very painful, and in result, we had a really tons and gigabytes of logs, because as already said, for the first we have switched on it in report-only mode, and what else? For the first, of course, we have tried to analyze these gigabytes with well-known Unix tools, grep, sort, head, and AVK, and so on. You know, it works, but not really good. After that, we have tried to add some Python and get in result some charts and the lists of, for example, top 10 blocked URIs, and have taken fun to understanding what is it. So, what problems do we have when we try to implement content security policy in really big project? First of all, as I already said, a lot of browsers have different implementations and different HTTP headers for content security policy. So after that, we decide to use, after see such situation, we decide to use only standard header and only standard content security policy implementation, which is available in the latest version of major browsers, except Internet Explorer. And what else? We of course had a lot of problems with third-party JavaScript libraries. Some of them use inline injections, for example, style injections or JavaScript injections, to identify current browser features of this browser and so on. But at the same time, it is broke content security policy paradigm. So, for example, you can search for content security policy in JavaScript or in jQuery backtracker. You will see a lot of bugs in it. But as I know, the latest version of jQuery works well with content security policy, so you can try it. The third one is interesting thing because I'm talking about mail service, and of course we need to take attention on HTML letters. Some of you like this letter, some no, but a lot of users send a lot of HTML letters, and it will be very bad news for them, if we, for example, try to switch off or throw away any styles, any inline styles. So these HTML letters will look not so beautiful. And unfortunately, we decide to allow unsafe inline for styles because of inline styles in HTML letters. And but also browser extension. Oh, it's very bad because it's very bad thing because when we for the first time try to analyze this ton of logs, there are a lot of Chrome extension stuff in it. So a lot of extensions try to inject content scripts into current web page, and it's not bad. But the worst thing that some of them try to inject external sources. For example, some kind of JavaScript from external host into current web application. So what this external code is doing in our client side? It was very bad news for us. And the second bad news is it's very difficult to identify what is this Chrome extension, the name of this Chrome extension, to, for example, ask the developers of this extension to fix the problem. So what was the way? And it's the current way from the report only to blog. First of all, we, of course, fix all related bugs. And another interesting thing that when we try to analyze this ton of logs, we have also find some bugs which will be very difficult to find simply by testing the application. So in this situation, content security policy with reporting can help you, for example, to debug your application and to find some deep stuff in it. The second, as I already said, we decided to use only standard HTTP header and the low browser extensions and also low unsafe inline for JavaScript. I'm trying to understand you why we done this thing, because we have some code generation on client side, so we simply can't throw away unsafe inlines for JavaScript, unsafe eval for JavaScript. So there was something like things that we need to do when we try to move to block mode. After that, we have some tips for you. If you want to implement content security policy in your web application, first of all, you need to teach your web developers, front-end developers about this cool feature, because some of developers, for example, will ask you about very interesting questions. For example, if we throw away inline scripts, we also will take decreasing of speed, so we can do it, and you will need to describe them how can we fix this, or how can we find some maybe solution to throw away inlines. The second one is if you want that content security policy will be widely implemented in your applications, you of course need to add it to your checklists and so on for new products. And of course, don't forget about mobile versions. And it's very important to research core components or core libraries of your web application and tries to find which parts of them will block content security policy. And after that, you need to talk with your developers and try to fix it. And of course, it will be great if you will have some responsible developer in each project for content security policy implementation. And at the end of my presentation, I want to present you interesting idea. How many of you use IDS, intrusion detection system? Oh, great. Imagine that you will have millions of sensors. As you might guess, it's browsers. And if you, for example, implement correctly content security policy with reporting URI, you will have opportunity to know about all cross-site scripting attacks on your application. All these browsers, all these sensors of your users will send cross-site scripting attack information to your magic black box. And this magic black box will try to ask your developers, for example, to make some ticket in your bug tracker system. And after that, it will be tested and fixed. So the good thing that, what is the difference between, for example, parsing of web browser, of web server logs and this content security policy based IDS? The difference is this event means that some attacker bypasses your content security policy, and in most cases, it will mean that attacker had found cross-site scripting issue in your application. So in ideal world, it will be means that you have a problem and you need to fix it. So, in conclusion, of course, content security policy it's not really panacea for cross-site scripting attacks, but in the same time, it's good yet another level to protect your users against cross-site scripting attacks, and it will be great if you will implement it. So to be continued, and I can ask you your questions. And what also, I have two gifts from Russia for two interesting questions. It's 2 bottles of vodka. I'm joking. I have 2 big chocolates. So I will give you for interesting questions. The first one and the second one. So if you like chocolate, you're welcome. Thank you.
Okay, thank you very much, Taras, for the very good talk. Are there any questions?
Chocolate, big pieces of chocolate.
Go get them.
Oh, I remember you from the last conference in Athens, in Greece.
And now I'm getting back to you.
Yep, I remember that I have asked you some terrible questions.
Yeah.
It was not mine.
I'll be nice. I was wondering, when you had this situation of legacy web applications and you are trying to deploy CSP for them, you notice that you have some bugs or you're violating the CSP policy. That might not be a bug, it might be just some old handling of the anchor tags with JavaScript colon in the href instead of having onClick and such things. What did you do? Did you contain the old legacy code in iframes, or did you actually manage to tell people to rewrite this old legacy stuff?
It's a really interesting idea to move it to iframes. We try to, with our developers, we try to remove this stuff simply by implementing it in another way by JavaScript. So, but I think I can give you a chocolate because of my question on the last conference. Here you are. You can take it. It's Russian. Yep. Hey.
We still
Another
have
questions?
some more time.
Oh.
I start over there, then I come to you.
Did you notice any performance impact on the clients or the servers?
Your question is about how it influence on performance on what side? On client side or server?
Well, it's only a tiny header that you send with the servers, but did you notice any performance difference?
The only thing about performance is about client-side performance, because you know, you need to, for example, you can send your data in one response, and if you implement content security policy, you will need to move JavaScript stuff to external sources and try to include it in your client side. So it can influence on performance on client side, but I don't think that it can somehow influence on server side. Because it's from server side, it's simple one HTTP header. What else?
Could you give me a little bit of insights on the total effort to actually do that on a large application? How many man-months? And how is that spread over the application, the different steps you say? And does it scale with the application? So is it a fixed effort to start with, and then for every page or every 1,000 pages, so much more? Can you give some insights on that?
Oh, I don't sure that I correctly understand your question. Could you please make it shorter?
So how long does it take for an application? Have you any rules on that to actually migrate from non-CSP to CSP?
You're talking if we have some rules to implement content security policy?
How much time, how much effort?
Oh, how much effort? Is my experience, it's really take a lot of effort to implement content security policy if your web application have a lot of JavaScript and really rich user interface. So it's much better to implement it on the first stage of construction, of development of web application. It's simply so. The main effort is to ask and to make developers know about this feature and agree that you need to remove external code. So it was the main effort.
And is it actually something that scales with every page? Or is it once you fix a few of the bugs in the framework, for instance, that they are using, or the libraries, then most of the other pages go for free?
We fix it in, mostly we fix it in our core libraries of this web application. Oh, any questions?
Back to the performance, was there, because you had to move the JavaScript to another file, was there more network traffic involved? And
yes, I already said about it, that it will influence on client side because it will need to remove inlines and JavaScript to external sources.
but was it a problem increasing the bandwidth at all, I suppose, because some people are very sensitive to how much bandwidth they use.
Sometimes it's a problem, yes.
Did you have any problem with dynamic JavaScript and externalizing that into separate files?
Sorry?
JavaScript that depends on like dynamic values, because you couldn't, usually you might cache those JavaScript files, but no, you can't, and you can't dynamic view.
You can cache it. Yes, you can cache it, and it will influence on speed and so on client side.
Okay, I just have one more question. Ashar was the first, but the time is almost up. Who gets the last presents? You can already think about them.
Oh, I think I throw it to the room.
I am Ashar. I had a very simple question. Because you have implemented CSP on a scale. This is some scale. Yandex is a big website. So how do you see, what is your personal opinion? How do you see CSP in the next 5 years? Do you think big organization, big businesses will start using CSP, or is it really a painful task to use CSP? So what is your general opinion?
As my opinion, content security policy is really good and elegant feature to protect cross-site scriptions, and I hope it will be development because, for example, when you try to read mailing list of people who develop content security policy, there are a lot of good ideas in it, and I hope that all these ideas will be implemented in next version, on next versions of content security policy. So is this my answer? And I think I can give you a chocolate. Thanks.